3 dimensions. For a cube A, B, C, D, E, F, G, so it's 8 point, E, F, G, H, so 8 points, so that gives you a cube. As shown at the right, using trigonometry to find the following, correct to 2 decimal places where necessary. Be careful that errors do not accumulate. Okay, so anyone understand what the sentence means? What means like errors do not accumulate? When the error will accumulate? We have talked about that before. When you round it, we will have error. So if you use the rounding number in part B to work on part C, then the error will accumulate. Okay, that's what the sentence means. It's warning you that do not use rounding values. Okay, you shouldn't use rounding values. If you're using rounding values, the error accumulate and the answer is not exact. The more time you use the rounding numbers, the more accurate you will get. Okay, so that's the warning here. Okay, let's have a look at this question. So for 3-dimension shape, well, we don't really like 3-dimension shape because it's hard to see what's inside. But what we can try is to put 3-dimension into 2-dimension shape. Okay, into 2-dimension shape. So let's have a look at this question. Find the angle of BAC. Okay, BAC is here. But you know when you draw 3-dimension shape, it's not really, well, for example, it's a square on top, but you can't really see a square. What you see is a parallelogram. So it's very like, the shape is not actually what you see as on the graph. So what I will do is get this shape out. Okay, we will have a look which 2-dimension shape contain BAC. What shape contain those 3 points, BAC? So we see A is here, C is here, B is here. So we can draw this. You know that's a cube. So DABC must be a square, right? That's what you know. DABC must be a square, like this. Now it's back to 2-dimension question, because what it's asking is the angle for BAC. We connect that and we're looking for these angles. Okay, what's the size for this angle? 45. Thank you. 45 degrees. Because it's a square and we draw the diagonal, we'll cut the 90-degree angle into half. So we get 45 degrees for BAC. Okay, and then I want to find the length of AC. Okay, length of AC. So it's this red line I sketch here. So this is 2-dimension shape. It's easy to work out the value. So it's a square. We have 1 and 1 as 1 unit. Okay, the length for each side is 1 unit. So what's the length for AC? What's the length for AC? Can't be 1. How we can work out AC?
Pythagoras.
Pythagoras, thank you. So how we can use Pythagoras to work it out? What's the value?
1 plus
Yeah, 1 plus 1 squared plus 1 squared equals to AC squared. So AC squared equals to 2. AC will give me root 2. Okay, AC gives me root 2. Alright, let's have a look at the next one. Next one asks for angle of AC and G. Okay, normally we're trying to look for squares or rectangle or right angle triangle. Okay, so that's the 3 basic shapes we're trying to look for. So let's have a look at CAG. CAG is here. Can you give me something like this? Like what shape you will give me to work out the angle for CAG? Like I work out BAC, I have drawn the square. Okay, so if I want to work out CAG, what kind of two-dimensional shape you can give me? Right angle triangle. So which right angle triangle you will sketch? What? Where is that? ACG, and where is the 90-degree angle?
ACG.
ACG. Okay, angle ACG is the 90-degree one. So let's do this. Okay, so let's say that's C, that's A, that's G. What value do you know? Like what length do you know? 1. Which is 1?
CG.
CG is 1, okay. Anything else you know? A, what?
AC is root 2.
AC is root 2, okay, thank you. And what's AG then?
Root 3. Oh wait. Yeah. Root 3.
Yeah. Oh, getting lost. No, no. My computer become a little bit weird these days. Root 3. Okay, root 3. Okay, smaller, please. Please. It's not in the. Okay, that's better. Okay, that's the. Okay, right angle triangle ACG. So angle C is the 90-degree angle. And I know the length AC, CG, and AG. AG is by using Passec to work that out. Well, I have worked out AG. That's root 3. Okay, root 2 square plus 1 square give you 3. So square root 3 is AG.
Sorry, I was doing it so like it up.
Okay.
Oh, please.
Yes?
Is this that the values have to be correct to decimal place?
Yeah, we can do that in calculator later. I want to keep everything exact and in order to not accumulate the error, and then I can do everything after that. Okay, so how you can work out CAG? Angle CAG. CAG is here. So let's say this angle theta here. Tan inverse. Yeah, we can use tan inverse. Anything else we can use?
It's like A.
Anything. You can use sine inverse. You can use cos inverse. Okay, let's quickly think about that. Theta equals to sine inverse of what? Okay, it's quick test.
1 over root 3.
1 over root 3. Okay, good. Okay, theta equals to tan inverse of what?
1 over 2. 1 over root 2.
1 over root 2. Good. And theta equals to cosine inverse of what?
Root 2 over root 3.
Yep, good. Thank you. So that's the 3 ways we can find the angle theta, but they all should be the same. When you type into the calculator, everything should give you exactly the same answer here. Now we can, well, that's why I don't expand root 3 as decimals, because I want to keep the root 3 in the exact form, then put in the calculator to evaluate the angle. Now after we find out all the expressions, we want the final answer, we can put that into the cast. Well, part A is, alright, it's exact values, 45 degrees. Okay, anyone know, instead of putting in the calculator, what's root 2? It's a number really easy to remember.
1.5.
Close. Close, really close.
1.4.
1.4. Okay, so root 2 is 1.414. Okay, 1.414 is approximately the size of root 2. Well, there's more decimals after that, but I just remember 3 decimals. So give 2 decimal places is 1.41. Why does pen get so weird? Let me clean that. 1.4. What? 1. Okay, I will close it and then restart it. I think it will be better. Okay, it's better. Oh. Okay, 1.41, that's root 2. What's root 3? Have a guess. What's root 3? 1.7. I heard someone say that. Yeah, that's correct. The next decimals?
5.
Too large?
1.717. 3.
I think it's 1.732 for root 3, so it's 1.73. It will be very useful if you can remember those root 2, root 3, and root 5 values. If you can remember that for year 11 study, it will be very quick to approximate something. For example, it will ask you to sketch the graph. Okay, what's happening there?
Sorry.
If you are to sketch the graph for example, x-intercepts root 2 over 2. So, well, if you don't have the calculator, you just want to know where approximate that point is, I will say, okay, what root 2 is 1.414, and I divide that by 2. It's about 0.7. So I know approximation position for that. So it will be good to remember root 2, root 3, and root 5. All right, the last one I can't really do in my head, so I will go to use the calculators. So what I will have, I will use the sine inverse, maybe that one. Come on. Sine inverse 1 over root 3. So I'll keep that in exact values. Root 3 and 1. Okay, so 2 decimal places will be 0.62. Okay, 0.62. And if you have your calculator, you can try other values. That should give you the same thing. Oh, wait, sorry. My one is in the readers form. That's in pi. I need to change my setting. That's why the angle is very small. Okay, copy that down again and Control Enter. So 35.26 degrees. Okay, 35.26 degrees. You will learn what is radius form later, like next lesson. You will know that. 35.26 degrees for the angle. All right, that's the first one. Can you have a look at the second one? Well, if you need, you can have a discussion with your like people next to you, how we can make a 2-dimension shape for the next one. Okay, so my purpose is change 3D questions into 2D questions. So for this shape, how we can set up, you can put ABCD on this diagram, is fine. So how I can make 3D graph to 2D graph to answer this question here? Can you try to do example 2 and example 4? Okay, you skip 3 first. You do 2 and 4. Okay, trying to solve that. If you need help, just ask your friends near you. I will come back to that. Let's have a look at example 2 first. Example 2 asks for the angle of elevation. So you need to remember angle of elevation is the angle made with horizontal. So that angle theta is the angle of elevation. And well, you can see there's a right angle triangle here. Let's say if that point is A, that point is B, that point is C. So we have A, B, C here, which AC is the AC perpendicular to BC. So it's the height perpendicular to the radius. And then I can have the theta there. I'll use tangent theta equals to 11 over 6, and theta is tan inverse of 11 over 6. That gives me 61.4 degrees. Okay, 61.4 degrees. I feel like everyone have worked out too. That's no problem. And if we can move on to example 4. If we can move on to example 4. Example 4 is the triangular faces of the right square basis pyramid are at angle of 60 degrees. Okay, it's already labeled for you. OB and AB make an angle of 60 degrees. And the height of the pyramid is 30 meters. Find the perimeter of the base of the pyramid. So it's a square base. Okay, it's a square base. Correct to 1 decimal places. Okay, if we have a look at this diagram, we know OA is the height. Okay, OA is the height. O is the middle of the square. Okay, O is the middle of the square, and OA is the height. Height is perpendicular to the base, right? Then the height is perpendicular to any line on the base. It's perpendicular to the base, then any line on the base will be perpendicular to that height as well. So OB must be perpendicular to OA. So the angle O must be a right angle. So I can have this angle here, AOB, and I know OA is 30 meters, and that is something we can work out. But why we want to work out that length? Why we need that length? It's not really the base the length of the square. But we can see OB is half of the distance of the length of the base. Can you see, like, OB is half of this. Okay, OB is half of this. So if we can work out OB with times 2, that gives me the one side length. And then I can times that further by 4 to give me the perimeter. Okay, to give me the perimeter. So what I can do is use tangent. Tangent 60 degrees will be 30 over OB. And I can work out OB equals to 30 over tangent 60. Okay, a lot of you evaluate this already. Okay, I see a lot of you already make, that equals to 1 decimal places, something like that. But I feel you don't really need to give decimal places here. This is not your final answer. And that is already a value. You know that's a value. I will just keep this expression. Okay, I'll just keep this expression in my further calculation. But I'll introduce something in the calculator. Like, I think it's really important for year 12 study. Is you can store or define values as a letter. For example, you think something's really long. I don't want to type in the calculator every single time. Like, you know, in your scientific calculator, you can do the same thing, like store a particular value into A, like into a letter A or letter B or letter X. You can store values as a letter. For example, what I want to do now is I know that OB is 30 over tangent 60 degrees. Okay, I know that's the value of OB, and I don't want to use this every single time. So I will go control. Can you see the control above the equal button? And VAR is the button above 9. Okay, VAR is the button above 9. Can you see the store STO, like the thing there? So you will have an arrow like this. Okay, control VAR. Press control first and then go for VAR. You will have this arrow here. This arrow will be give the name of this expression or give a name of this number. So for example, I want the name to be OB. I'm not sure if I can do 2, but let's try. Okay, let's say OB. That's the length of OB. And I will press enter. Okay, to store it. Okay, to store it. You can see that give you the calculation value. And then I'm not sure if I can store as 2. Yeah, I can. So 2 letter. Next time when I recall OB, it looks different. Can you see it looks different on your thing? You get looks like that. Okay, and now when you press enter, you will have exactly the same value. So that letter OB represent this value here. Okay, represent this value here. So this is how you can define a value. So when you have some really complex numbers and you don't really want to recall it every single time and don't want to go up for many steps to copy that value, what you can do is you define the thing when you calculate that out. You may feel this not that important year 10 study, but it's so important for year 11 year 12 study. And because I'm introducing this, I'll introduce another thing. Well, I don't think you can do that. You don't learn function notation yet. So let's remember this first. So this arrow is called defined. Okay, defined. You have defined OB as this value here. Okay, you have defined OB as this value. So every time you recall OB, that will be 10 root 3. So remember what I said. I said OB is half of the length of the square. So I will times 2 by OB by 2, that will give me the length of the square. And I'll further times this by 4. Okay, I can just leave my OB here because that's the value I found last time. And go Control and Enter. That will give me 138.5, so 0.6 to 1 decimal places. Again, this is not that helpful in this question because the expression is not bad enough. Okay, but when you do something like really a lot of decimals, like even many decimals, not repeating irrational numbers, that will be really good to define it as a letter, not necessarily as OB, maybe just as O. Okay, just define it as O. Yeah.
So what if you want to like get rid of it?
Menu, actions, you can clear A to Z, clear history, clear the variables. You can clear 3 of that, it will clear everything for you. Any other questions? Okay, if we don't have any questions, you can start work on your homework. Question 3 will be a question in your textbook as well. So you can just skip that and do the homework.